Hello, my name is Chris. This is the week 9 of me working on the F-110th car. Today is a Tuesday, August 7th, 2018 in the morning. I was gonna say early morning, but for some people, 7:54 might not be early, and for some people it might be really early. But some of the things I want to talk about, I didn't make a video for last week, so I'll reflect a bit on the progress from last week and kind of what I'm feeling right now. But from a high level, right now it's August 7th, so it's basically this week and next week are going to be the probably last 2 weeks I'll be working on the car in terms of course development for the new class, before I become a TA in the fall for that class. So, speaking of that, the topics I want to talk about. So last week I worked a lot on the neural network, which is really exciting, but also very disappointing because I didn't get it working very well at all. And what I ended up using was, you see on the car behind me, I used the Z camera, but I was only using one of the cameras, so I wasn't even using it really for the $500 capabilities of using the depth cloud and stuff. I was literally just using it for the camera because it mounts well and because the camera looks decently nice with like an f2.0 aperture. But I trained the network. I used something called Google Collaboratory to run this code that Matt actually shared with me, which is based off of the end-to-end learning NVIDIA paper. And let me just make sure it's recording, by the way. And that paper was something I always wanted to try. That was the whole reason I joined F110. I'm so excited, looking forward to this as an end goal. Finally got there. There's already code. This 19-year-old USC wrote it in TensorFlow. It's only like 3 main Python files and some. But basically, I wrote a node that would save the Z VGA images. They're like 600 by 300 or so. Pretty small images, like 1 point something megapixels, and as well as the steering angles during training, and run maybe 10,000 images, about 7 minutes of driving, and then give me some type of save output with the model checkpoint. And it just didn't work very well. I tested it inside using manually driving and pure pursuit driving, and it was just basically crashing into the walls. And then I also tried it outside. Not crashing into the walls, it veer into the wall. Sometimes it'll turn correctly, but most of the time it just goes straight on and turn into the wall. It was very disappointing because that was like what I was really looking forward to this whole summer. Like, I was so excited, like, I have this car platform, I'm gonna get it to train on neural net, I'm gonna get it to drive outside and like dirt paths and stuff. But as I actually thought about it more, I also realized that neural networks, maybe it was influenced by Professor Mongeram, but he was telling me that the problem with them is it's like a black box. So you don't really learn that much from the control point of view because you don't know why the car is crashing. You know what the output is, but you don't really know why it's making prediction, and so you don't get that type of nice function, input-output functionality, which is actually a good point. But I'm also just, this week, the first half of the week at least, I'm working on doing explicit planning for the car, so I feel like I'm going backwards. Professor feels really strongly about doing wall following down hallways while having like a high level planner code where you can just tell where to turn left. So basically what I'm doing right now is the car will go down a corridor, and it only works in most certain environments too, not very generalized. But it'll go down a corridor or hallway, and when it detects an opening, it'll then fetch the next instruction from a CSV file, which allows it to then change its wall following from center to left to right and turn. And it works decently well now that I have a timer based on how long it follows something for. And it can also change the velocities just as waypoints. But I'm thinking that one of the things that needs to be improved is that when I'm trying to do a fast wall follow down a hallway at like 2 meters per second, I get this problem where, just as a visual from video, you see these metal plates over here? That causes the car to miscompute the distance, and as a result, the car ends up drifting towards it. And normally when the car is going slowly, it drifts towards it, but as it gets near the end, it realizes, because it's a direct reflection, that it should drift back away. But when it's going fast, it doesn't have time to recorrect, so it just ends up crashing to that corner right there. So that's a problem, and so professor said to tape up all the walls, but I don't necessarily agree because that's like a hack. I don't think it's really engineering it. I think that's just like trying to fix the problem in a very localized way without really fixing the actual algorithm. So I'm gonna try and think first if there's a way to fix this actual algorithm. Maybe just discard extraneous values. That's something I could do, I guess. Yeah, pretty much. I was gonna say do a left wall follow, but that wouldn't work because I need to follow left and right, or mostly just left. So yeah. One other thing that I've been looking into is something called the Orb Slam 2. So this is Orb Slam. It's using like Slam for monocular cameras, just normal stereo cameras, and somehow they're able to compute this map and also know where the car has moved, the robot has moved, which is actually really insane. I tried running it though, and it's a little complicated, gives some compiler errors. So I'm really tired for some reason. I slept till like 1 a.m. after salsa dancing last night. I woke up at like 7:30. I don't know why, and I had an eye mask on too, so I don't know why I woke up so early. Yesterday I woke up at like 7 as well, so I'm just a little tired. So that's something I'm looking into as well. I'll end this video earlier, but basically that's what I'm working on just this week, next week. Later this week we'll be working on Hector Slam, just to make sure that the Hector Slam is working, pretty well. I mean, that's not what I'm saying. Hector Slam, we can't just have the students import a ROS package for their homework assignment. We need to give them some part of it to implement. So that's what Husam's gonna think about and assign to me or Jack to work on. So that's the thing. Thanks.